Hello, this is Joe's Physics Corner, and today we're going to solve 2009 Step 3 Section B, question in 2009 Step 3 Section B Mechanics. So the question is number 9 of Step 3, and first of all I'm just going to read the question. The question says, a particle is projected under gravity from a point P and passes through point Q. The angles of the trajectory with the positive horizontal direction at P and at Q are theta and phi respectively. The angle of elevation of Q from P is alpha. So part I here wants me to show that tangent theta plus tangent phi is equal to 2 tangent alpha. Before I solve the question, I'm just going to draw how the system looks like. So if we have the y-axis here and the x-axis here, I'm going to draw how the particle is going to move from point P here to point Q, because the question says the particle is projected from P and ends at Q and passes through Q. So let's say point P here is the origin, and we know that it doesn't really matter where we set point P to, because what we're interested in is just how the trajectory looks like, not how we could define the coordinate. So that's why I'm going to define the coordinates P and Q as any arbitrary points, and for P I'm going to give the coordinate 0, 0, which is the origin. So let's set Q here with not a set coordinate yet. And we know that the shape here is going to be a parabola because there are no other forces than gravity acting on the particle that's being projected from P. And so we could draw a parabola that looks like this. And we know that this will continue onwards after it reaches Q and form a perfect parabola shape with the coefficient of the highest order a negative value. And we said that this here is point Q. One important information, three important informations given by the question is firstly that when we have a gradient, an instantaneous gradient like that, we know that the angle here is going to be theta, because it says that the angle that the point makes at point P, the particle makes at point P with the horizontal axis is going to be theta. And so we know that this angle here is theta. We also know then, by the same logic, that the angle that this gradient here makes at point P with the horizontal axis, or the parallel to the x-axis, is going to be phi. And the last bit of information we know is that when we link these 2 points together, we get the angle here as alpha. So these are basically all we have extracted all the information from the question and represented in this diagram over here. Now, before I did this, I mentioned that we could label P and Q as any two arbitrary points as long as we follow the guidelines written on the question. This means that when we draw a vertical line from Q to the x-axis, when we set this length here, we get the height here as m tangent of alpha, because due to tangent being opposite or adjacent. And so first of all, if we try to define the equation of this parabola over here, we know that first of all, we have y equals, and we do not know what the coefficient of the highest order. So we set that as a. And we do know that it has an x-intercept of 0, so we say it's going to be x times some point here on the x-axis that we don't know yet. And so I'm going to define this point here as k, 0 and say it's going to have a factor of x minus k because it has an x-intercept at point k. Okay, if you say that, we could expand this term and get something that looks like this. And because we know we're dealing with the instantaneous gradients, when we take the derivative of y, we get 2ax minus ak. And here we know that when y prime at x equals 0 is going to be equal to tangent theta. Because tangent theta is basically opposite over adjacent at point P, of the instantaneous gradient at point P. And so opposite over adjacent would be the same as rise over run, which is the gradient. And that's going to be tangent theta here. And so if you plug in x to y prime over here, we get y prime at x equals 0 is equal to, we cancel this form here because x is 0, and get minus ak is equal to tangent theta. This means that we could represent a here, which is the coefficient of the highest order, coefficient of x squared, is going to be equal to minus tangent theta over k. Okay, so we used this point over here, and so now we're going to use, before we do that, we're just going to plug in a to this equation here for now. And so we get y is equal to a, which is minus tangent theta over k, as defined here, times x minus k. And now the second point we know, the second bit of information we know is that we have defined the coordinate here as m, comma. So yeah, because we have basically defined q as m times m tangent alpha. When we plug in this coordinate over here, we get m tangent alpha is equal to minus tangent theta over k times m minus k. When we expand this term, we get minus m tangent theta over k plus tangent theta. And for now, I'm just going to leave it like this. Yeah, I'm going to define this equation in terms of m tangent theta over k, because I know that in the future that's going to be quite useful when we're dealing with the gradient over here. That's going to be m tangent theta over k. So that's alpha because we're dealing with this here. So alpha, yeah, tangent theta plus m tangent alpha. And now, given that we know this, we're going to move on to the last bit of information, which is that the gradient here is going to be equal to tangent phi, with the same logic that we used to define the gradient over here. And so we get y prime at x equals n, because the coordinate of q, the x coordinate of q is n. We get the y prime, the instantaneous gradient of the function over here at x equals m is going to be equal to tangent phi. And we know that this is equal to plugging in x into 2ax minus ak, we get 2am minus ak. And here we defined a, so we could represent all of these in terms of k and the angles. And we get 2m times a, which is minus 2m tangent theta over k plus tangent theta. And we said that this is equal to tangent phi because it is the gradient, the instantaneous gradient at here, which forms the angle phi with the line parallel to the x-axis. And here you can see the reason why I represented this expression here as tangent theta plus m tangent alpha, because we know that this expression here is basically minus 2 times this expression over here. So we get that if we multiply minus 2 to this, which gives the same expression for minus 2m tangent theta over k, we could say that minus 2 tangent theta, which is minus 2 times tangent theta, minus 2m tangent alpha, which is minus 2 times m tangent alpha, and that's equal to this here. And write the following down. When we rearrange this, we could get, well, minus 2 tangent alpha theta plus tangent theta, so we get minus 2m tangent alpha minus tangent theta is equal to tangent phi. And so 2 minus 2m tangent alpha minus 2 times So there's a mistake here. We have to define this here as m times tangent theta because we have to multiply the m out. And so we get m tangent alpha is equal to even before doing this, we could cancel the m out from this equation and get tangent alpha is equal to minus m tangent theta over k plus tangent theta. And so we get the expression for m tangent theta over k as tangent theta minus tangent alpha. And now that will solve our problem. So in this expression, we could say that with the same logic, we could say that this here is minus 2 times this expression over here. So we get minus 2 tangent theta plus 2 tangent alpha plus tangent theta is equal to tangent phi. And so when we arrange all of them in terms of 2 tangent alpha, we get 2 tangent alpha is going to be equal to tangent phi plus 2 tangent theta minus tangent theta. And so we get tangent phi plus tangent theta. And here, this is basically the answer to showing why tangent theta plus tangent phi is equal to 2 tangent alpha. And notice here that although the question did mention that the particle is always under the effect of gravity, so minus mg, what I thought was that defining the equation of the system in terms of mass, in terms of gravity, is just going to be unnecessary more work, because all we have to know is that the projectile of the particle will be in the form of a quadratic equation. And so it is quite unnecessary to represent the projectile here in terms of the mass, the gravitational constant, and etc. And that's why I took a mathematical approach rather than a physical approach, knowing that the only necessary information we need to solve this problem is the fact that the path will be in the form of a parabola. And so yeah, that's how we solve part I here. And next video I'm gonna be solving part II, which is quite of a more difficult problem than this over here. As always, thank you very much, and that was my video.